Stars. On behalf of the organizing committee, I welcome you, sir.
Thank you.
Sir, honorable respected speaker of first session, Dr. Shushanka Karmakar, sir, from IIT Guwahati has already joined us. And on behalf of the organizing team, I invite our Honorable Vice Chancellor, sir, to be chief patron in the organizing in the inaugural ceremony and deliver his inaugural speech to formally start the program. Sir.
Okay, so today's FDP is on the AI and machine learning application in healthcare system. So far, I believe.
Yes, sir.
And this is a very good initiative again from the Department of Computer Science. At the outset, let me welcome AICTE, and this will give certain amounts of credit to all the participants because they will be able to use it at their career advancement afterwards. But that is secondary. Primarily is it will sensitize a very fascinating area in digital healthcare systems, which is going to be the future, where numbers of applications of different software tools and techniques in healthcare will be prevalent and will have widespread applications in not only in this country but across the entire world. And all the participants, of the teachers who are interested to pursue a research career of formidable importance, and also who are interested to enrich their knowledge in academic domains for the benefit of the student community, it will be an unique opportunity. And here, I believe, and this is my conviction, that all the speakers have been carefully chosen, who are experts, who have been working in this area for a significant period of time, for sharing their experiences, their unique experiences with all the participants who are present. You see, right now, there's a time is coming where we must engage ourselves in the culture of self-learning, because a numbers of these resources are available in a public domain, which was not this a case even 10-15 years before. Many documents that were this restricted and were not made for public this viewing and public consumption. But today, in this digital in the world of where digital revolution has taken places, so numbers of resource materials, course materials, contents are available in online platforms, and where there will be no dearth of opportunity if anyone is seriously interested to learn anything. Only thing that is required right now is a sensitization for developing the curiosity in the mind. And that is very much required. If you develop your curiosity, if you develop an inquisitive mind, then there is no barrier for enriching yourself, acquiring knowledge from different corners. So this is the real situation now. And we are organizing this faculty development program. This is not the end by itself. This is an initiation. And from here, the journey will start for a numbers of participants who are interested to pursue a research in this area. And my advice to all of you is, you see, we do many things. in limited numbers of areas, we can connect our level of motivation with the inputs which we are receiving. That's why many of the inputs which we are receiving, that do not stay permanently inside our mind. And if you take serious interest, if you want to this take up research areas in this particular domain, then uh, here you will get enough opportunities for developing this little level of understanding, or primary level of understanding at least, amongst you. And there will be enough opportunity to interact with the faculty with the resource persons, whereby those who have certain level of knowledge, they can further this plan or strategize their courses of action to take up many these important activities, innovative activities in this area. So these are the opportunities for beginners. These are opportunities for those who have a little bit knowledge, and these are also opportunities those who have profound knowledge, because they will have the chance of interactions and networking with the numbers of participants, numbers of resource persons over here, to validate their level of understanding and to form their own community. And here from this university, we have taken an initiative to set up a center for digital healthcare systems. This year, we tried to introduce a course in this area, particularly for first time in this particular part of this country. This is on digital healthcare and telemedicine, and with the designing of course curriculum, taking inputs from numbers of professionals belonging to these IT domains, healthcare domains, pharmacy domains, management domains, and other areas. We have started this activity, and we are hopeful that maybe initially we are getting lukewarm response, but within the shortest possible time, as the market is growing, depending on the demand of the market, a numbers of young minds, they will be attracted to these particular programs. And this area, this is going to be very, very important, because healthcare is one of the things which determines the health of the nation itself. Because if you do not have a healthy nation, healthy population, your number of man days or working hour gets destroyed, and eventually the potential which are there among the large populations of India, that the scope of using that potential is lost to some extent. But this is one thing. And the second is, we have to make up homogenizations in providing affordable healthcare and quality healthcare across the entire population, to avoid unnecessary expenditure in healthcare. So that is also another thing where technology intervention is very much required. After technology interventions, the things become affordable, things become more this quality driven, and at the same time accessible, and at this and there is always the scope of homogenizations and uniformity. So with this, I would like to congratulate the Department of Computer Science for taking this endeavor in organizing these faculty development programs. And I believe that all the participants, all the faculty members from the Department of Computer Science will take up this activity very, very seriously for developing a formidable research and learning community in this area, because this is the time for this development of a research community. And with the inclusions of all the resource persons, and with the development of a number of these professionals of the futures as an outcome of this program, that will help in cherishing our dream in near future, which we are looking for to this use educations as a service for the betterment of mankind. With this, I'd like to conclude. Thank you very much. And I declare the conference, this 5-day FDP program, as open.
Thank you, sir, for your illuminating and inspiring words. We are always benefited with your positive directions, even if in the pandemic situation. when we were able to continue such kind of activities, not only such kind of activities, various activities with support from our university and our Honorable Vice Chancellor, sir. So now I would request Dr. Somdatta Chakraborty, Madam, Director IQSSL, to say a few words. Madam.
Thank you very much. A very good morning to all the dignitaries in the panel and dear participants. It is really heartening to note that the university is organizing the second ATAL FDP this year, that is based on the theme applications of AI, ML, and DL in smart healthcare. The first one was conducted in the month of July 21 by the Department of Information Technology. And this is the second one conducted by the Department of Computer Science and Engineering. We have two more in the series, one by Microelectronics and VLSI, and another by the Department of Biotechnology, which is scheduled next year. So from my experience in the previous one, I felt that AICTE has made the task of conducting workshops much easier by routing all the workshop activities through its ATAL portal, starting from participant registration, workshop attendance of participants, uploading of lecture materials, taking feedback from the participants, then uploading of test questions, giving marks, and finally the certificates. So everything through the ATAL portal. So this has made the task of the coordinator and the participants much more easier. So I'm sure that the next 5 days are going to be very interesting and informative for the participants, as the theme of the workshop is very relevant in the present times. Attendance is mandatory for all the participants, and this is a criteria to be able to give the test to get the certificates on the final day of the workshop. So it is a nice initiative to be able to host this FDP on this very important area. And my very best wishes to Dr. Suparna Bishwas for its successful conduction. Thank you very much.
Thank you, ma'am, for your kind words. Many a times I have sought your help, like whenever I had any doubts regarding processing of these FDP related issues. Thank you, ma'am, for your support. And next, I would like to invite to say a few words from our senior most professor of our department, Professor Shushanka Acharya, sir. Sir.
Thank you, Suparna, and Honorable Vice Chancellor, my colleagues and the participants present here. So the application of AI, ML, and DL in healthcare system is a burning issue today. As the number of patients is increasing with the increase of population, the healthcare system becomes more and more complex. For example, if we see the problem of diagnosis, means clinical decision, there we find a good application of AI-based system. What it is? So we normally keep our data in an unstructured way, where some relevant data may be covered with some irrelevant data. And when a doctor will go through some unstructured data, he may be confused and he may miss any relevant data, which will be a great risk for the patient. So if the data are filtered on the basis of relevance by some AI techniques, then it will save the time, it will give accuracy in diagnosis. So it can be done by natural language processing. Another application may be mentioning very simple applications. That is primary care. Okay. If we see some symptoms in our body, which may be not important, but we contact doctors, okay, for that simple issues. And doctor says that, okay, it is nothing. But the money and time of me and of doctor, actually, that is an wastage. So if there is a system, AI-based system, which will take the queries of a patient, simple queries of a patient, and there is a chatbot system, it will give you proper direction. It will give the patient some advices which he can take and apply without going to the doctor. So if it doesn't work, then he may go to doctor. This will also save much time, and doctors actually may concentrate on crucial issues instead of these simple issues. So it will save the time of doctor also. There is robotic surgery where AI-based system is used for operations. So we know that if the operation is prolonged, means if it takes long time, then the human being, the human doctor who is operating, he may get fatigued. But the robot he is not tired. Okay, it will work with the same efficiency all the time, and the operation also will be very precise, and the occurrence of error is minimized. So this robotic system also is also working today. And finally, a new paradigm has come, which is called precision medicine. In precision medicine, the treatment is based on individual patients. So nowadays, actually, we see that if the symptoms are common to all the patients, the drug is also same. But in case of precision medicine, suppose it is caused by some genes, suppose it's a genetic disease, then the symptoms may be same for all the patients, but the treatment will differ from patient to patient depending on the expression of genes. So this is very new paradigm in healthcare system, and it will give us more accurate treatment. So I think the experts are there to deliver lectures during 5 days, and you, the participant, will be benefited by these valuable lectures, and I hope success of this program. Thank you.
Thank you, sir, for your wonderful elaboration. Sir is one of the eminent speakers in our program. Tomorrow, our session we will hear from him, but on different topic, holistic development of personality. Thank you, sir. So I would like to welcome Professor Debashish Dev, Director, the School of Computational Science, and also Professor of our department. Sir.
Good morning. Thank you, Shuparna. Very good morning to everyone. Honorable Vice Chancellor, sir, our Finance Officer, Dr. Atri Bhumik, and also our IQC Coordinator, Dr. Sundatta Chakraborty, and my dear colleagues. Today we are gathered for a FDP, ATAL FDP on healthcare, and this is a very interesting and important topic. And if you see the FDP calendar in India, at least 60% is coming with AI and machine learning. That indicates the needs of the hour, and a lot of people are working in this domain. And already our previous speaker have mentioned that the importance of this healthcare technology. I just like to mention 2-3 points that not only we are organizing this event, some of our faculty members are actively involved in this healthcare technology. For example, our convener of this program, Dr. Suparna Vishwas, she is working on the remote healthcare, especially for using wireless body area network, W-band, and which is extremely helpful for senior citizens to take care of the healthcare, because the senior citizens are facing a lot of problems because no one is there to take care. So she is developing some model. I have seen they have developed some projects also. I think she got a project from West Bengal DST.
Yes, WBDST.
WBDST. So sometimes I'll be happy to see that you can show at least for some time you can showcase those things to all the participants, because all the participants are coming from all over India. They can know the strength of our university. So that is very important. Next, I'd like to mention that our Dr. Sriparna Shah is junior, but she is very energetic, and she is doing excellent job on brain-computer interface, BCI. So, and she has also some project from ACRB, and she is developing the models for healthcare using brain-computer interface. So this is an excellent topic, and using the EEG machine we can do the analysis of the healthcare, which is extremely important because this we can read the mind. I think she is an expert in that domain. Maybe sometimes, maybe for at least 10-15 minutes, I will ask her to show within this FDP, because that will give you the idea what kind of work we are doing in our university. And I can see our ADF, means AICTE doctoral fellows are there. Ahona Ghosh and Tonustri, they are also working very hard for this domain. Also, I can see Dr. Shoykot Basu. He did his PhD from IIT Kharagpur in the I think health. That is also in healthcare, mind reading and mind mapping. So I think he has made a copyright on certain healthcare system or health games. So that is very important that using the game also we can understand the psychology of the human being. So this psychology is also a very important part of healthcare. So Shoykot can also give a very interesting demonstration, at least for 10-15 minutes. So that is extremely helpful that people are working, because during this pandemic we are all become psychological patients. So Shoykot has some solution how to improve it, what kind of methodology we'll use for this modern healthcare. I should mention about our Professor Shushanka Karmakar. She is doing excellent job on healthcare, and actually he is developing the models of soft computing in the domain of gene analysis, or I think those gene analysis and how to predict the disease. I think he has published some paper in IEEE transaction. So we are really proud of you, sir. And I think that these are our strength. This is our strength. And already our Honorable Vice Chancellor sir mentioned that we are in the process of development of digital healthcare. Yes, digital healthcare is the future. And the problem is that when you go to hospital, because after the heart attack, right? After heart attack or after our health become extremely deteriorated. So this is the century we are actually going for. There's a very important proverb is there. Prevention is better than cure. Prevention is better than cure. That means you have to be monitored 24/7 basis. So that any problems that can be detected earlier, and doctors can also help the patients, means all the participants, all the participatory participants, means the patients in their whole ecosystem of healthcare. By that process, they can prevent the heart attack. So we should not go to the hospital before, after the heart attack. So heart attack can be also prevented. Also in our university, we have, I should mention that we have a healthcare department in our university, genetics department. They use karyotyping. I think many of you may know it, that karyotyping, I think it is started by Professor Subroto Kumar Dev. I can remember he took my blood sample and he told me that you may have the heart attack possibility at the age between 45 to 50. So he has predicted. I have given my blood sample. So using the karyotyping process, you can do the gene mapping, and that can also detect what kind of disease they can do it. We can detect. So this is kind of predictive healthcare. That can be predictive maintenance, and predictive healthcare can be done. So these are the various technologies we are developing in our university, and I think that will be extremely helpful for the society. Sorry, I have taken a lot of time. Thank you, Shuparna. Thank you. Thank you very much.
Thank you, sir, for highlighting some salient features of our department related to smart healthcare and remote healthcare project and relevant things that are going on. And so, thank you. So, Finance Officer Dr. Utri Bhumik is amongst us. He has keen interests in various such activities. I am happy to invite you, sir, in this inaugural session. So after we hear from our finance officer, we would welcome our speaker of the first session, Dr. Shushanka Karmakar, sir, who has already joined us from the very beginning of this session. So I would welcome our finance officer, Dr. Utri Bhumik, to say a few words.
Good morning, everybody. Honorable Vice Chancellor, Sir, Professor Shuipat Moitro, who is our constant source of inspiration, Professor Devashish De, Dr. Suparna Vishwas, who is the coordinator of this beautiful program, Dr. Somdatta Chakraborty, Director IQAC, my colleagues, respected resource persons and participants. We feel extremely privileged today to organize today's 5-day FDP program sponsored by AICTE. We hope that this program is going to be very interesting and productive for each and every participants of this program. Thank you very much.
Thank you, sir, for your time and being with us. There are so many finance-related supports we needed earlier and we will need in future to compile all the tasks related to this FGP program, and we are thankful for your support. Thank you, sir. So with this, we are end of this inaugural session. So with due permission of our Honorable Vice Chancellor, sir, we are moving forward to the technical session. Sir?
Okay, thank you. I close this inaugural program.
Yeah, thank you, sir. So the speaker of first technical session, Dr. Shushanka Karmakar, sir, is amongst us. So I would like to over this session to him to begin with the first session, and his topic is looking at smart healthcare through a lens of distributed computing. Sir?
Okay, thank you.
So I would, yeah.
Let me
Sir,
share the
please,
screen.
yeah, share your screen and I will briefly introduce sir with all our participants and dignitaries. Dr. Shushanka Karmakar passed BE and ME both in Computer Science and Engineering from Jadavpur University in 2001 and 2004 respectively. He did his PhD in Computer Science and Engineering from IIT Kharagpur in 2009. Since December 2009, he is associated with the CSE department of IIT Guwahati. His primary research interest is in distributed algorithm, fault tolerance, distributed optimization, etc. He has guided 4 PhD students. He is a member of ACM and EATCS, European Association of Theoretical Computer Science. He has published around 50 articles, including journals, conferences, book chapters, etc. And just a few lines on his talk. Smart healthcare has been a very important research direction in recent times, especially after the advent of COVID-19. Healthcare is undergoing a rapid transformation from traditional hospital and specialist focused approach to a distributed patient-centric approach. Among various technologies, communication technologies have enabled to deliver personalized and remote healthcare services. This talk first introduces various aspects of smart healthcare. It then clarifies the role of distributed computing or algorithms through the imposition of a structure among the devices used in a smart healthcare system. The talk discusses about the structures and the related costs to create and maintain them. The talk finally concludes with some important future directions. With this, I hand over the session to Shushanka Karmakar.
Okay, thank you, Dr. Suparna. First of all, let me thank Honorable Vice Chancellor, Sir, Professor Shuipat Moitro, and the other organizers of this FDP program on smart healthcare and application of AI, ML, and DL, and respect other dignitaries. I thank you all. So I hope I'm audible.
Yes, sir.
Okay, so let's start. So the title of the talk is looking at smart healthcare through a lens of distributed computing. So I will bring the relevance of AI, ML, etc. with this at the latter stage of the talk. So when we look at smart healthcare, three questions comes in my mind. One is what it is. The second thing is why we should go for it. Okay, and the third is how. Okay, so one by one, there are many other questions maybe, but I will mainly focus on these questions. So first thing is, what is smart healthcare? So it is the provision of health related service, as the name suggests, in a smart way. I mean, not in the traditional way, in a smart way. How smart? It is done by using a network of intelligent agents. Okay, and it's a context aware. Okay, context aware. I mean, that means where the agents are working, that context is relevant. What can be an intelligent agent? It can be a computing device, it can be a mobile device, it can be some sensors, some smart band, or maybe a surgical device, or maybe some device that measures the blood chemistry. Okay, or device, as mentioned by some of the some of the professors in the inaugural session, that we can measure brain waves. Okay, so those devices can be acting as an intelligent agents. There are also human actors in this system, in this smart healthcare system. They are patients and the healthcare providers. Healthcare provider means nurses or doctors or similar identities. So, so they form a overall system to provide some service. What is that service? It is some healthcare related service. So how it looks like roughly? It looks like this. So we have patients, and say patient 1, patient 2, and there are sensors attached to them in some way. And then through those sensors, we measure important metrics or data, and that is fed to some server using communication technologies. Now, once the data is fed into the server, they are available to different users, say doctors, nurses, or maybe say other hospitals or other private organizations for say some sort of survey generation, for some sort of reporting or etc. Okay, so this is roughly the way any smart health care system works. Okay, so the second question, that is why we are interested in smart healthcare. So one important thing is the access to data. Okay, that is very important, because without this access to the data related to smart healthcare, we cannot progress, or we cannot develop different applications. We cannot make interesting things. Okay, just to give an example, Google X, which is a sub part of Google, they have developed a contact lens that can measure glucose level. Okay, so that data, glucose data of a particular human being, that can be measured, and through some wireless technologies that can be fed to some server, where from the corresponding doctor or monitoring unit can check and take proper action. Okay, so this data is very important, not only from a doctor perspective, but also from a patient perspective. The patient may not be very aware that due to intake of this or some item, the glucose level has risen so much that maybe it may be fatal at some point. So accessing different medical data, especially online data, is very important, very much important. So that that is one of the reasons why we are going for smart healthcare. You can say, okay, I can go for the traditional way, but then traditional way, as you can understand, one has to go with a blood sample or maybe do it at his own home with some testing device, okay, that may not give the desired level of promptness that can be obtained through this kind of devices or this kind of mechanism. The second is the connecting multiple agents. The different agents that I just talked about, they are to be connected, okay? And why they are to be connected? Because they can provide some meaningful decision or information for the betterment of the patient or betterment of the system. So if this glucose level or say pressure information goes to a doctor, then based on that, the doctor has specialization and can take the appropriate call that he or she probably need some kind of medication immediately. Okay, maybe an insulin shot or something. So the third thing is autonomous action. So autonomous actions means depending on the present health situation of a patient or some area, we should take some proper action, and that action up to what extent that can be automated. Okay, definitely injecting insulin is not automatic till now, but the procedure of invoking that can be made autonomous. Okay, some message should go to the person that yes, your sugar level is high enough so that you need an insulin injection, kind of thing. So this kind of proactive mode of healthcare is needed for better healthcare. Okay, so there may be many other answers to this why. Just one more thing I would like to say, giving an example, which I sometimes think, if you have a car, suppose, if you treat the car well from the very beginning, then probably it will run a long time. I mean, say 10 years or 15 years without any trouble. But if you do not take care of it, then probably it will become bad very quickly, and it will take a lot of costs to repair it at a later stage. So these are also some of the reasons that we go for smart healthcare. Now, there are many other benefits of smart healthcare. As I should not elaborate on this, I think everybody knows. We can remotely monitor a patient, which is very much important for village areas or some other places, remote places where there is not enough medical facilities, and self-management of important health conditions are also there. So for that, some smart healthcare will benefit the patient. Performance improvement is another important aspect of it. Behavior modifications. Behavior modification, to give an example, suppose due to irregular or intake of bad or non-desirable items lead to fluctuations of different body parameters. Okay, so if an online checking mechanism is there that this has changed, then the person will probably, there may be some mechanism to predict that, okay, probably you took some bad intake, and due to that, these parameters changed, okay, which is detrimental to the health. So proper behavior modification can be invoked. And the thing that I was talking about a little early is that early detection and diagnosis. Okay, so there are many diseases actually whose early detection and diagnosis are very important, and that early detection can lead to almost cure of that problem. But a later detection may be fatal actually to the health. So to do this early detection and diagnosis, smart healthcare can take a very constructive role. Okay, and better treatment. Better treatment means if it is early detected and the exact issues are displayed or informed to the relevant experts, then definitely we can go for a better treatment. Okay, so these are some of the benefits of smart healthcare. There are many others as well. So if we think of healthcare system, then okay, so if we think of the healthcare system, it has different sub-components, and those components are classified in this picture. Roughly, this is the classification. There may be other ways of classification also. So if you look at the healthcare system as a system, as an application, then it has different users. That application has different users. So smart devices themselves can use such a healthcare system. Early warning system. So maybe there are special kind of deadly diseases for which early warning is a very fruitful thing. So those early warning system may use such a healthcare system, and may benefit the society in a huge way, especially women and others. So in monitoring the health of elderly people can use such a system. Forecasting systems. Okay, so whether certain group of people are facing some typical problems, okay, those kind of cases, healthcare systems are useful. Now, there are who will be the end users of such healthcare systems. So hospitals may use it. Hospitals may be part of the system, as we showed in the earlier picture. Home-based patients. Okay, there may be patients who are not so careful about their own physique, but if such a system is installed, they may have a look at it through their handheld device, and they may be a little bit more careful. So home-based patients are very much important for this kind of smart healthcare system. Government bodies will definitely benefit a lot from this healthcare system, because they will have a lot of data in their hand for a state or country like ours, and they can do a lot of research activities. Clinics, research bodies, all these people, they will be benefited. Especially there are other beneficiaries like diagnostics labs. Okay, now if you think of smart healthcare system, then there are different components, and one of the components is the software component of it. Now that software or hardware, you can say software hardware component of it, and for that we need different resources like database. Okay, so that database has to be maintained in a proper way so that it can be universally accessible in a secure and reliable manner. I mean, what part of the data especially we have to be very careful because patient data is very much privacy concerned and vulnerable. So those, I mean, the security privacy issues with this database is of paramount importance. Remote access, of course, I mean, this database should be accessible to proper or authorized users in a remote and transparent manner. There is a network involved to access this smart healthcare system, and this network may involve different technologies. Okay, so such a network should be constructed, and different protocols and technologies related to that network will need to be studied properly. Of course, security, privacy are some of the major concerns in healthcare systems, and safety. Safety, of course, I mean, when security, privacy comes into picture, safety automatically comes into it. Then there are other services. Okay, services who will use this online healthcare system as a service, and they may benefit, or they may use this as an input to some other software system. For example, let's say insurance companies, they may actually use this healthcare system as a service. Now, there are medical devices, as we discussed. There may be body sensors and other things who will be part of this system. And there will be technology components. Technology components means like different connectivity technologies like NFC, mobile phones, satellite, Wi-Fi, and so on. So these are roughly the different components that we should take care of. There may be others as well. So this is a very small example of how healthcare system, smart healthcare system works. So maybe there is a heartbeat sensors or blood pressure sensors, and that goes into an IoT device like a Raspberry Pi or something, and then it goes to a gateway server, and then through the internet it goes to different people like the doctor, like some other server, like some PC or something. Okay, so this is a small example of how such a system works. Remember, in this system, I have not shown any human actors, but they are also agents in this system, so they may be there. So another example here is this person has different body sensors attached to it, and there is a local processing unit, which may be a tab or a mobile, and then through that the data goes to the different regions. It may go to the family, it may go to the hospital, and it may go to the local physician. So maybe this guy is running in the park, and based on the current physical situation, maybe one ambulance may be rushed to pick him up and get him admitted to the hospital for immediate checkup because of some abnormal anomaly in the body parameters. Okay, so this kind of online systems are very important for immediate healthcare. So now, if you remember, I talked about why, what, why, and how. How part I have not yet discussed, so we'll come to that. So what can be the application of this healthcare system? So as we saw that we can design a framework for patient data gathering in smart healthcare system using Raspberry Pi or similar devices. So especially I'm talking about this data gathering problem. So remember, in a huge country like ours, gathering of data can be of immense importance. Okay, and that data, if can be stored and mined, okay, then and analyzed, then lot of deductions can happen in the healthcare area. So gathering patient data is a very, very important application. The second application that I am very much fond of, and maybe you will also be, is combating COVID-19 like system, diseases, okay, using a smart healthcare system. COVID-19 is one thing that came very recently, but there were other such smaller pandemics people would not know. As we know, through contact tracing, especially infectious diseases, we need special way to take care, and this smart healthcare system takes a big role in combating these kind of problems. And if you can determine the potential infection in the neighborhood. So there are many small apps, as you might know, that are installed in the mobile devices to understand these potential threats, and you avoid going into those potential threat areas, okay, to save yourself. So this can be very useful. So overall, there are many other applications. Let's not spend too much of time on these. So I quickly mention some of the applications here. You can look at them. Okay. So in a word, there are innumerable number of applications, and it has a lot of potential, this smart healthcare. So now, what are some of the challenges that we face in smart healthcare? Okay, so definitely one of the biggest challenges is security and privacy issues. So as you know, that the gadgets or the sensors or devices or the agents, they are connected, including the medical and mobile devices, and they aggregate the data and transfer the data into the cloud, okay, or some server, and from that server, actually different authorized people like doctor, nurse, or some other third parties, they monitor the data and they take some necessary actions. Now, so there is these devices, if they are actually these devices are actually attacked in some way, then this privacy is lost. Okay, so these devices are very much important. Security of these devices, and in different layers, actually in the different protocol layers, there may be security issues, as you might know. So there may be spoofing, there may be jamming, there may be other ways of security threats. Okay, and especially in the medical condition, this is really serious. Just to give an example, that I believe you all know that how sensitive it is that somebody is infected with COVID. I believe that this is the case, that okay, you can show the count, that okay, the count of COVID is this, but you cannot say he is COVID infected. You cannot name him, something like that. So those kind of specialized things should be. So privacy is a very big issue in healthcare. The second, how to enforce this privacy and still achieve the sharing of information. Okay, that is the main problem. So there are other issues like healthcare information exchange barriers. Remember, as I discussed earlier, that through the picture, that the healthcare information that is shared into the cloud, they can be visible to the doctor, relevant doctor, or to the nurse, or to third parties, okay, for different purpose. But how much data? He has a lot of data fed into the server, but not everybody should be able to access everything. Okay, so there should be some sort of access control over the amount of data. Okay, so maybe the doctor in that particular hospital under whom that patient is admitted, he may have full access to that data, but maybe other doctors, or maybe maybe other doctors need some special authorization to have a look at that. Maybe other doctors of other hospitals may have fewer authorizations. Okay, and especially private institutions may be interested to conduct a survey on some disease or something. So for them, maybe very small amount of data should be exposed. Okay, not much. So what should be the proper way of access control. That is very important. Okay, so this information exchange in a reliable and secure manner is a very big issue. And then, of course, the computer science part or technology part comes in it, the device communication. There will be various heterogeneous devices involved in such a system, and different protocols and communication technologies are used by these devices. So, of course, I mean, we need to do a lot of work on this. So, and collection and management of data. So the data, once collected, they have to be managed in a proper way. Okay. I mean, I needless to mention that there are a lot of inherent issues. They are small, just one-line statement, but there are a lot of inherent issues in each of them. And as we know that this healthcare system design and implementation is not a single discipline problem. It's a multidisciplinary problem involving chemists, involving computer scientists, involving, say, physicians, involving, say, psychiatrists, involving, say, physiotherapists, and many other dimensions may be there. So it's a multidisciplinary knowledge. So design and implementation based on this multidisciplinary knowledge is not easy. It's a complex way to deal with. So now, given all, so these are some of the challenges. Now, where the distributed processing or computing comes into the picture. Okay, so let me highlight a little bit on that. Okay, I hope I have half an hour roughly. So as I told you that there can be several important applications which are related to distributed processing in smart healthcare. So one of my favorite applications is information gathering tool design for collecting patient data. Okay, and when, before, during, and after a process. I mean, let's say that process be a surgery. So before the process, we have to collect the data. During the process, we may need to collect the data. And after the process, we need to collect the data also. Okay, so this information gathering is very much important for different jobs. There may be distributed patient monitoring system. Okay, so as you know that in remote places, in a big country like India, the patient monitoring is not strong enough. Okay, we have to think it in a more pervasive way. You think of some problem that is happening in the village level. I mean, there is effectively almost no monitoring of such situation, that whether the treatment is proper or he is being properly taken care of. So a distributed way of monitoring at different levels, say from district level to higher levels, such a distributed monitoring should be there. And of course, distributed resource allocation is very important, especially in a body area network, where the patient is fitted with different devices for effective monitoring and physical status determination. So these are various applications that I am talking about where distributed processing is important, is necessary. So there are many other areas where distributed processing is important. One is, suppose, in today's smartphone-based real-time health monitoring. Okay. Now, as you know, that security or privacy is an important issue. This intrusion detection, whether some intruder has detected and they have captured some device and taking control of some device, is pretty much serious, and we should have some sort of real-time detection mechanism of those. Okay, for wearable health care devices. Now there is a scope of edge computing, which is a special form of distributed computing. Those who are aware of this, edge computing means there are these devices, and some data these devices need to be processed. Now, they need not be sent to the server. They are processed very close to the locality of the device. These are called edge devices. So there are edge devices, and there are some other devices. And the edge devices get data immediately from the sensor devices, and then they process, and maybe they send the processed data to the servers or somewhere. So this edge computing has a strong role over there. And distributed problem solving in COVID-like situation. So here also a little bit of processing is needed. I'd like to mention just one point where in recent times we suffered a lot. This COVID situation, getting a bed, okay, in hospitals is a very serious problem. Leave apart the money part. Okay, suppose I have the money. Even then, I mean, getting a bed is a very important issue. Not only that, but the movement should be minimized because of the infectious or contagiousness of the problem. So first I should have a check whether in the block level I have hospitals and I have a free bed. And then if I fail, then I should probably go a level higher, like district level, and then maybe in the state level. And then if in my state all the beds are occupied, suppose, then I should go for other nearby states. Okay, so such a hierarchical way of solving the bed finding issue for a potential COVID patient who is suffering in a serious manner is to be solved. Okay, otherwise we cannot take care of the situation. So distributed problem solving in infectious diseases is very much important. So here I listed a couple of applications where distributed processing is involved. Okay, and this information gathering or data gathering in such a system is one of the major applications. Now I come to specifically where what is the role of distributed processing, more into it. So there is something called network structure. Okay, so it means there is a structure of the network. Okay, that is important for this smart healthcare. Okay, so what can be a structure? I will come to that. So one of the more important structure is like Steiner tree. Okay, or a special version of Steiner tree, which is called a price collecting Steiner tree. And these kind of structures are very much important for team formation in multi-agent system. Okay, so these different devices or these different components of such smart healthcare system, you can think of as a multi-agent system, and you need to form a subgroup of them. Okay, so it's called a team formation. A team formation in this multi-agent system. So basically, here you look at the picture, it may be clear. So there are many nodes here, and the red ones are the terminals. Okay, and basically we should form a team of such terminals. But the question is, the team is to be formed in such a way that there is a path from from one team member to another team member. There should be a path. Okay, now here I can have a path like this 2, 13 and 4. Okay, but the cost of the path is becoming more. It is 19. Okay, but the way that I have connected here through these orange links, you can see if I take the sum of the edge costs of the orange link, it is 4 plus 6, 10 plus 2. So it is 12, which is much smaller than the original cost, that is 19, comprising only of the team players. But here the problem is I introduced 2 green players into the system, 2 additional players I bring in. Okay, they are called Steiner vertices. Okay, and as a result, this total cost is smaller. Okay, so if addition of some more members can reduce the cost, then I will do that. So the objective is to connect the team members in such a way by taking some additional people into the team, so that the path cost, there is a path from every team, one team member to all others, and some of the edge costs that connects the team members along with the additional members, that is minimized. Okay, so this is one of the problems in team formation, and this is often known as the Steiner tree problem. A special variation of the Steiner tree problem is called the price collecting Steiner tree problem. So we will roughly look into it. So now let me switch slides, and for some time I will discuss on what we have worked on this kind of problem. Okay, so I will stop sharing and reshare probably.
Yes.
Okay. Okay, I hope this new screen is visible.
Yes, sir.
Okay.
ST problem.
Yeah. So this is the technical definition of the Steiner tree problem. So which says that given a graph G, okay, with weight function of positive real weights, okay, and a set of vertices Z, okay, which is called the terminal set. The goal of the Steiner tree problem is to find a tree T prime, which is a subset of vertices and a subset of edges, such that some of the costs of the weights, some of the weight costs, okay, edge costs is minimum, subject to the condition that the V prime, which is the total set of the tree, that is a superset of the terminal set. That means that contains at least the terminal elements plus some additional elements if required, but has to be a subset of the original set V. Okay, and the edge set actually is a subset of the original edge set of the given graph. Okay, so there is a concept of these terminals and the Steiner. Okay, now the question is how, I mean, this is the problem, and this is an example basically. So if you look at the picture, which is top left corner, then it's the graph, and these black nodes are the terminal nodes and white nodes are the other nodes. So I have to connect somehow all the black nodes. Okay, so look at the two other pictures that are presented here. I can connect them using the red links. Okay, so in one of the connections, let's say the connection is T2. Here the cost is 7 basically. So 2 plus 1 plus 2 plus 2. So that is 7. Whereas if you look at the way I connect it and the left bottom, then the cost is more. It is 8 T1. Okay, so the goal is to get T2. Okay, the desirable goal will be to get T2 because it has a lesser cost. And remember, to have this lesser cost T2, I have to go through 2 white nodes here. Whereas in this picture of T1, in the tree T1, I only go through 1 white node. Okay, so I take one additional node that reduces the cost, but not good enough. If I take 2 additional nodes, I can reduce the cost even further in this particular picture. Okay, so this has many applications. Okay, one is this phylogenetic tree of life. This is a biotechnology application, and this also has applications in healthcare. There are other applications of these problems, like in communication network, multicast tree formation, team formation, VLSI design, etc., etc. So with that, I will not elaborate, but just will like to highlight the contributions that we made. Okay, so if you can look at the work done in the table, it shows that we gave this factor distributed approximation algorithm for the ST using order of S plus square root of n log star n rounds in the CM. CM means it is the congest model. Okay, so there is a special model of distributed processing which is called congest model, and there we gave this much of time and this much of approximation factor. So why this approximation factor? Because this problem cannot be solved optimally. Okay, even in the distributed setting. I mean, forget about distributed, even in the centralized setting, you cannot solve this optimally because this is a hard problem. Okay, it's known as NP hard problem. Some of you might know. So we give approximation algorithm, and this is the round complexity. Remember, this is a distributed processing, distributed algorithm. And then we show that there is a round message trade-off. Round message trade-off means if I want to improve the message complexity, there is some messages involved in this. So message means I need to communicate with other devices. So I need to communicate. So the total amount of communication, that is some parameter there. Now, if I try to reduce the message thing, then probably the number of rounds go up a little. Okay, so that's why there is this. This is the round message trade-off. Okay, so where I was. Okay. So okay, just a little. Probably I moved quickly. Okay, so this is our contribution. I wanted to mention that look at this table that I'm sharing here. In this round complexity and the message complexity in the approximation factor, the line, the row marked red is our contribution. Okay, so we have done some work in this line. So this is, it may appear this is actually purely design problem. Okay, so how better you can design the structure. Okay, that's one of the problems. I'm not going into the details, technical details, because that will be more involved. So I do not want to go, but these results are already published in journals. Okay, the Journal of Parallel and Distributed Computing. So I will just mention some of the other problems that are interesting. Okay, the second work that we did is the same problem, but for a slightly different model. Okay, this model earlier was CM. CM stands for the congest model. Okay, congest model means it's a connection of the nodes in a network, but one node can send log n amount of messages to only its neighbors, and it cannot communicate beyond its neighbors. Okay, that's the model. And in each round of communication, one node can send log n bits of messages, where n is the number of nodes in the system. Whereas in this model CCM, there is a second model called CCM. This is called congested click model. Okay, in this congested click model, the idea is that all the nodes are connected in the form of a click. Okay, and in that click, in one link, you can send log n bits at a time. Okay, in one round, you can send log n bits. Okay, and there are different variations of that, but we consider this simple model like congested click model. If you are more interested, you can look into it in the Google. Okay, so for this congested click model, we solved the same problem, and we came out with slightly different results. Okay, we came out with results with taking the soft toe of n to the power of 1/3 rounds, and we proposed another where it depends on even smaller rounds, s plus log n, okay, rounds, where s is called the something closely related to the diameter of the network. Okay, so these are some of the problems that we solved, and there is the third work which we solved, which is called the price collecting Steiner tree problem. So this price collecting Steiner tree, as I told, it's a slightly different variation of the Steiner tree problem, and you can see the formulation in the internet. I'm not going to discuss here, it will be a little heavy, but we proposed some memory efficient distributed approximation algorithm based on some primal dual technique. Okay, those of you who are familiar with the linear programming paradigm, okay, they may have a understanding that what is primal dual technique. So using that technique, we proposed a solution which is memory efficient, and we proposed several future directions. Okay, so these are roughly the works that we did in this structure formation. Okay, so this table that you can see now is roughly the picture of our contribution. Although this is a little more theoretical, and it mainly related to the structure of the network that in turn helps in the design of a healthcare network system. Okay, so let us for the time being stop and go back to the original presentation. So this is the Steiner part, and we made some contributions in the structure formation. Okay, now with this I will go for further future directions where we can make some contributions. So one is of course this direction known as distributed artificial intelligence. So as you know, that artificial intelligence is essentially multi-agent system. Okay, so there are multiple agents communicating to solve some problem. And distributed artificial intelligence means the agents are distributed in different places, and they are communicating, they are coordinating, okay, and solving the problem in a distributed manner. Okay, we have some projects in this distributed artificial intelligence, distributed agent systems, where our goal is, I mean, we take a simple problem like it's called a data delivery problem. We have suppose a path graph, okay, and how efficiently we can transfer data from one end of the path to the other end of the path by incorporating a minimum number of agents. Okay, that kind of work we have done. There are of course various other related topics like distributed approach to the ML or machine learning. I have to admit that we are not I'm not an expert in ML, but I know a little bit of it, that it needs a little bit of training of data, and then with that trained engine, you actually get decisions on unsupervised data. Now, this training that you do, natural question is, can that training be made distributed if the data training set is too big? Okay, I mean, is it worth? So some kind of work is going on in that line also. And now another work that we have started, and it is online, is that dynamic strainer tree. In practical sense with the healthcare network, sometimes in the healthcare network, the link may go down, okay, or some new link may be introduced in the network. Okay, some nodes may come in, some nodes may go out. Okay, so that's the nature of dynamicity. And what happens that in these kind of dynamic systems, there are two approaches. One is you run this algorithm from scratch to regenerate the structure, or if the number of changes is small, then you can do a little bit of tweak and you can recreate or maintain the structure so that it satisfies your desirable properties. So those are some interesting things. I mean, you do not need to change the whole structure. For a minor change, so one edge has been introduced, you just need to change the strainer tree a little bit. Okay, so can you locally update so that your modified structure is good enough? You do not have to change it entirely. So those kind of ideas we are looking at. Okay, so with that, I will conclude my talk, and these are a few references I will suggest. That there is this paper I got, this smart healthcare architecture, taxonomy, challenges and future directions in IEEE Access. And there are some resources in Google that I used. And of course, I used some resources of our work with Parikshit Saikia, my PhD student who has passed who has got the degree and he's employed somewhere else. So these are some of the references that I have used. So I thank you again, and I'll be happy to take any questions.
Thank you, sir. Am I audible?
Yes, yes.
Yes, thank you, sir, for the very first session, which actually sets one second. Which actually sets the true spirit of our FDP, and which actually is focused on the smart healthcare with the application of the intelligent techniques that are already in place, so that the daily human life, maybe it is only for old peoples or who are age-old people who need some monitoring help, or it can be for the kids monitoring, or it can be for the health monitoring, or it can be for the just for the fitness monitoring, whatever can be the thing. And not only the monitoring. Hello.
Yes, ma'am. Yes, ma'am. Please.
Hello.
Yeah, go ahead.
Yeah. So what can be the thing? Can be the simplest monitoring, or can be the complex disease identification, prediction, or rehabilitation? Any kind of support, if we can provide with the help of technology, then that will actually help us for betterment of daily living of human being. So we are very much thankful to Shushanka sir, who is from the very beginning amongst us, from the inaugural session actually. So sir has elaborated on some important aspects, and there are many more sessions to come, so that the participants can continue with the learning process. So now the session is open for interaction. So any participant who has any question can post their questions in the question answer area, and one by one the questions will be taken by our scholars Ohana and Tonusri.
Yes, ma'am. Am I audible?
Yes.
Sir, one of our participants, Rishika Anand, has asked, which ECG sensor is good for real-time ECG monitoring? Which ECG sensor is good for real-time ECG monitoring?
The question is in the chat box. Yes, sir.
Sir,
Yeah,
can you? Yeah.
I believe that I don't have exact clue of this, but I know small radio-like devices through which ECG data is stored, and that is communicated actually as a image to the I forgot the name, but such a device may not be good enough uh, for real time. So real time means you have to. I mean, it's not clear to me that whether he means it is some attached body sensors or it is some kind of a little heavy device. So is the question real time ECG monitoring means I'm getting the data real time for the patient is stationary or the patient is mobile, and along with that I need to get the data. That is not very clear, but I believe that there should be some device which will be able to handle this. I do not know whether there are any special just like I said that there some special devices have been investigated which can trace the blood sugar levels at irregular intervals from the eye, and I don't know whether such a device is there to trace the ECG signals. I mean, if some device is attached to the chest and then it gets the signal in a small scale. I know there are radio-like devices that take care of it, but I am not very sure if there are even minuscule devices which take care of this problem. Professor Biswas,
Yes,
do
sir.
you have any idea?
Actually, we have one project, and there we have purchased one kit which is called My Signals Health Kit actually. And in that kit, there are some sensors. One heart rate sensor is there, but that is wearable. As you are saying, sir, that the patient is static or patient is mobile. So in case of mobility, that wearable heart sensor is going to cover only the indoor, means within a room. But if it is some within a building monitoring, or if it is outside monitoring, then that wearable heart sensor is not going to serve that purpose. So obviously we need to know the exact scenario, or the environment in which the patient is going to be monitored, or patient is going to be, the data collection is going to be collected. There are wireless heart rate sensors also, heart sensors also. So
Yeah.
there are
There are
and
pulse sensors. Yeah.
yes. So there are many, means over a range there are many such sensors. Some are with wireless communication technology like Bluetooth or Zigbee, but some are with only just connected in the with the Wi-Fi, and some are wearable. So there are many range, and according to the application or the environment that can be selected. So I think the
Sir, we
participant.
have one more questions, ma'am.
Yes. Okay.
There are
Amunda TK.
many
Yes,
questions.
sir.
Uh,
Sir, what is vitro and vivo sensor? From Amudha TK. One more question from Nirmala Bai. Is there any technique to find out the infectious diseases using AI?
Regarding infectious diseases, I think, see, for infectious diseases, one of the major problem is to not come in contact or in the vicinity of the infected person, and especially if it is asymptomatic. So that's why some kind of apps have already been created. People might know that one of the apps is the Arogya Setu kind of app. There may be other kinds of apps as well, where those who get infected and their data is some sort of shared all the time, remembered, and whenever their mobile device is on in a certain way, then others can be signaled that, okay, I mean, somebody in your vicinity is infected, so you refrain from going in that particular area. So that is one way. Another is contact tracing. Okay, another is contact tracing. I mean, if you meet certain number of people, probably your mobile device and another mobile device, they can interact, and it can pre-compute that, okay, you have met, say, 50 people today, and out of that, let's say some of them are potential infections. So probably one should be careful for the next couple of days that infection. If next couple of days he remains confined and doesn't develop any symptoms, it's okay probably. Or at this present time, he should get immediately a quick test, so that so this small techniques might help actually. So infectious diseases, unless there is a cure of it, if there is a cure, that is okay, kind of. But if there is no cure, then prevention is the only possibility. And avoiding becoming in touch or in the vicinity of the infected people, that probably is the only solution, unless we have a cure for it. I think that is the first line of defense. Of course, there are other things like treatment, vaccination, other things are just different way to look at them. But I believe, yes, there are applications playing a lot in this way. And different countries have developed different kind of contact tracing. And even I don't feel it is good enough that sometimes people are not, active participation of people are very important. I hope that answers the question to a certain extent.
Yes, sir. Next question is from Taruk Dash.
Yeah.
Sir, is it possible to see any biosignal real time in this global world? In any cloud platform can receive and upload high frequency samples?
I have no clue to this question, but I can
Okay,
only say that these are very high level thought process. You might have heard of SETI, SCTI, Search for Extraterrestrial Intelligences, through which these American organizations are trying to trace if there are extraterrestrial life through radio signals. But he is talking about biosignals real time in this global world. What does biosignals mean? See, any kind of signals, if you think, it has to follow the basic rules of signals. It has to be some sort of signals. If it is strong enough, it will go a long distance. If it is not strong enough, it will attenuate. It will get attenuated. So I think only limited frequency signals, they go outside.
Okay, sir. As we are approaching almost to the next session, only one more question we will be able to take now. And if you have any further queries, sir, if you please kindly share your email ID so that the
My email
participants
ID
can.
is I'm typing here in this chat box. That probably will help. I think I have stopped sharing my screen.
Yes, sir.
Okay.
So only one question. I'm just reading out. Last question. Is there any tool built exclusively for smart healthcare?
Okay. See, there are many tools, individual tools are being built, but I can tell that, for example, Practo or something, that is some doctor assignment tools are there, or Practo, you can check, okay, doctor patient assignment tools, okay, are there. But the problem in this global, in this smart healthcare is that it's a very holistic thing, okay, and not everything is very much standardized. There's some protocol has to be followed. That okay, this should be the standard way of sharing medical information, okay. So those sort of protocols, I don't see. They are very standard. So people are building such systems in a more ad hoc manner, okay. You can search. Practo is one such system, maybe. There may be other. As I said, that Google is creating one platform, one system where somebody can wear the contact lenses, and through that contact lenses, it will monitor the blood glucose level online, and it will be fed to some experts, and experts will actually give feedback to the people through their mobile phone, so that they get proper care at proper time. Because sometimes these executives or busy people, they do not look after their health in a serious manner, but it may be detrimental. So in this busy world, they are trying to develop some kind of device that may be helpful. Yeah, of course, there may be some other applications being developed by other big technology companies. I'm not aware of that. Okay.
Okay, so we are almost at the end of first technical session. So thank you so much, Dr. Shushanta Chakraborty sir, for your illuminating beginning of our program. And we are about to start the next section. So before we move on behalf of the organizing committee, I once again express our sincere thanks and gratitude, sir. And of
Thank
course,
you.
we
Thank
hope
you.
to have you in future events
Yeah,
for
sure.
prolonged connection with
Thank
our
you. Thank you.
departments and with our university.
Thank you, ma'am.
Thank you, sir.
Thank you. Bye. Take care.
Yes, sir. Same to you.